We're going to use integration by parts to find the integral of natural log of x squared. Note that ln of x quantity squared is ln of x times ln of x. But ln of x squared like this is twice ln of x, which is ln of x plus ln of x. Clearly these are not the same, so do not mistake ln of x quantity squared for ln of x squared. Those are two different things. We're going to use integration by parts. I want to briefly review what that is. If we take a product of two functions, u times v, and differentiate that product, we'll use the product rule of differentiation. It's u, first function, times the derivative of the second, which I call dv, plus the second function, v, times the derivative of the first, which I'm calling du. Integrating both sides, the integral of the product, or the derivative of the product, is equal to the integral of u dv plus the integral of v du. By fundamental theorem of calculus, the integral of a derivative is just a function. It's being differentiated. That's u times v. And that's equal to the integral of u dv plus the integral of v du. So solving this for the integral of u dv, we find that it's equal to u times v minus the integral of v du. Again, the idea of integration by parts is to let the unknown difficult integral be the integral on the left, call it u integral of u dv, call one of the parts in there u, the other dv, find du, find v, express the integrals as the integral on the right, and then subtract it from u times v, and hope that the integral on the right hand side is easier than the integral on the left. This can be evaluated. So let's start. I'm going to write this function like this: ln of x quantity squared times 1 dx. Didn't change anything. Multiplying by 1 is still the same function. Now, the rule of thumb when we apply integration by parts and the problem involves a natural log is to always let u be the natural log part of the integral. It may not always work, but it will work most of the time. And then dv be the rest, which in this case it's 1 dx. Differentiating u gives us 2 ln of x times the derivative of ln of x, which is 1 over x dx. And then finding an antiderivative of 1, we'll take the basic one, that is x, without adding any constant other than 0. So the constant of integration is 0. That's what we always do, or at least 99.9% of the time. In a later video, you'll see one of the examples where it's advantageous to select another constant of integration other than 0. So here's the integral, ln of x quantity squared. We're calling this difficult integral the integral of u dv, and now express it as u times v. I'll call it, instead of writing u times, we will write vu, x times ln of x quantity squared. So there's nothing to do here. This part is finished, minus the integral of v du. So let's write this. We have a 2 in front, and then we have ln of x times 1 over x times x and dx. So this integral, that's the integral. This part over here is the integral of v du. And you can see, after we simplify it, that it is in fact easier than the integral that we started with. So this is equal to x times ln of x quantity squared minus 2 times 1 over x times x is just 1, so it's 2 times the integral of natural log of x dx. Now this integral, without 2, there's an earlier video of this integral, how to do it, but I'll go ahead and do it anyway over here. If you want to refer back to an earlier video, that's fine, but I'll just go ahead and solve this. Again, leave the 2 alone. We'll come back and multiply the answer by 2. So we want to evaluate the integral of ln of x. We write it as, just like before, ln of x times 1 dx. We're going to let u be ln of x, as is the rule of thumb, dv to be 1 dx. So du 1 over x dx, and v x. The integral of natural log of x then is u times v x ln x minus the integral of v du. But notice that v is x, du is 1 over x dx, so the product is just 1. In this case, the integral on the right is extremely easy. It's all done now. This is x ln x minus x. Let's put everything together and solve this problem once and for all. So we started with the integral ln of x squared. It was x times ln of x quantity squared minus 2 times the integral of natural log of x. We just solved the integral of ln of x, so this is x ln of x quantity squared minus 2 times x ln of x minus x. And now we can add a c at the end. We're done with all integration. We just add the c at the very end once everything is done. So the final answer is the integral of ln of x quantity squared is equal to x times ln of x squared minus 2x ln of x plus, notice a minus and the minus, plus 2x plus a constant of integration c. We can factor out x, but this is perfectly okay.